Today I'll be teaching you about the birds and the bees. No, just kidding, just bees. So our function looked at a bee survey done a few years ago of 5 different states. We'll be interested in, we're going to create a menu with 4 options that'll loop continuously. We'll create a bee biography. It'll generate a picture and a pie chart. We'll do a table that'll allow the user to choose a gender, and it'll sort our 5 states based on that gender. And then we'll also have a bar graph that'll be generated for an individual state, and we can compare different gender populations and total bee populations that can be used for a variety of different things. So we'll need these files. This is our data file down here. Let's take a look at the data. So here's our data that we inputted. It's a lot of qualitative data, as you can see. Not too much quantitative, so what we're going to have to do from that is generate a lot of stuff based on these 3 categories: gender, species, and genus. In column 4 we have our state, so as I said we have 5 states. The 3 genders are male, female, and worker. And then we have genus, and then more specific of each genus is just their species. So let's take a look at some of the code. Here we have our main menu. We initialize our menu in. Here we hit a while statement, one of our requirements already. While menu in is not 4, so run continuously unless the user types 4. Here's the menu below. So let's run this and see what we got going on. So here's our main menu, our options given. Let's try doing option number 2, a bar graph of state genders. Pops up a main menu. Let's do Minnesota. So here we see number of bees in Minnesota. We can see a few things. A, the breakdown of female is way higher than male and worker bees, and we can see the actual numbers. So that'll be useful to compare, and we can see anything alarming. Next, after that, in this function, it'll prompt for the user to enter 2 states. Just type in, just as I'm doing right now. And what this does is compares the 2 in total number of bees and the total number of each. So you could see for any state if they had an alarmingly low population according to, relative to one of the others. This one is pretty balanced, but for some of them you'll see, even though the total number of bees might be the same, it has a very low worker bee population, or maybe a very low female bee or male bee relative to the total. So perhaps someone studying this might want to look at that data and say, hey, we need more, let's introduce some more male bees into the state, or what have you. So that is option number 2. Let's go back to our main menu. That's still looping. Let's see option number 3, a table sorted by gender. What does this do? Choose a bee gender, blah, 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 female. So, as we saw from most states, female populations are dominating in the bee world. Represent. So this ranks. This is doing data manipulation to rank the 5 states that we have based on gender. So Illinois had the highest female population, 91, Missouri following, and he noted below that this is based on the bees collected and not necessarily directly reflection of the bee population numbers and how they might break down, naturally. So let's go ahead and take a look at some of that code. Oh, first we actually need to go look at the bar graph code as well. Let's talk about that. So this is under option number 2, the bar graph that we looked at here. So we called menu 2 when we did the bar graph. Nested for loops. We have here the male count being added up. Basically, it's running through all the data, keeping track of each count, organizing it here for our bar graph to plot. Here, the menu being displayed. switch case statement being used. So we've had our for loops, nested and switch case already, and while loop. And then it'll generate that bar graph based on the user input menu. And then after was the comparison that we did to look at populations. So enter the two states. And then the next function that we just did was the table generating the genders of each state. So for this, it calls under option number 3 here, we're calling script number 1. Here's script number 1. He uses the menu, the switch case statement. So for each gender, so if the gender is chosen as male, it's going to run a different script based on that. So if it was male, it calls script number 4, takes data from his other scripts. He has a series of scripts, so his data is mostly stored in script 3. This one basically uses that data and creates the table down here and sorts it accordingly based on the user input being male, and will then generate that table and show us the breakdown. So all that's left now is option number 2. Or I'm sorry, we did this one. Option number 1. Let's just run through this again, show you how well it's working. Illinois looking good too. Boom, there's another comparison for y'all. And then at the end of, Iowa has IRB populations, you could see total populations as well. So let's look at bee biography. We have all these species. The reason we coded this, chose to do this, is maybe there's a picture, see a bee in the wild and you don't know what it looks like. Or you're reading all of this data, reading all these species, and you have no clue what you're looking at. I mean, look at these names. So you click on one, get a picture of it, beautiful. Oh, that's ugly. And get this beautiful music Olivia put in. So while this music is playing, our pie chart is being generated. And we'll look at what's happening specifically with this. So we had, hurry up music. So we had menu 1 was chosen. It called this function, correctly named. And there is our pie chart that just now popped up. So the output of this function was then put into the input of this pie function, which is exactly one of the requirements of exactly what we wanted. So when we typed in Wisconsin, that was the input. That input was placed as the output of this state, and then it was then used as the input of my pie function. So it generated this nice pie chart here of Wisconsin showing the breakdown of each, actually genera, plural, of bees of this state. So you could use this to see how diverse the state is in its species and everything, and also compare it to other states to see if, anything needs to be introduced or removed, or if anything is negatively affecting another population, what have you. So that's how that function works. Let's go ahead and dive into those. So the bbio, Olivia's function, first one called user inputs a state. Based on that, we'll list the series of species for each one, then plays the beautiful music, outputs the input, outputs the user typed input to mine. So now I have this function correctly named and saved. No output, we'll just generate the pie function, but we'll use the input from Olivia's output. So I'll read the data again, switch case statement based on the input. So we did Wisconsin, but here I have my comment. So if it was Wisconsin, it creates a category, runs through, adds up a state count anytime it recognizes that state. This adds the genus name, so whenever it is that, it keeps track of the genus that was for that state. Adds it to a list, then this will lump them into categories. Now this line counts those categories and then divides each category by the state count. What that does is creates a little vector D that is a percentage. Each value in the vector is a percentage of that, genus relative to the state. So it represents a pie, one slice of each pie. So we generate our pie chart here based off of that. And as we saw, it looks very nice. We can see that. So we have run through every option. Option 4, exit the program. Have a beautiful day. So basically what we've shown here, each function works correctly. We've shown our nested for loops. We've shown our 3 different data types, our pie chart, our table, and our bar graph. We have 3 different types of data manipulation, statistic manipulation, at least. We used all of our necessary loops, our nested. We use the output and use it as the input of another function. So we've hit all of our requirements. The main thing that we've learned, I think, from this was how important knowing how to load data is, and knowing how to get the data that you need from a large set of data can be difficult. And B, when multiple people are coding, in our small group of 4, when you're putting your individual code might work, but you have to make sure it's all agrees with each other when you put it all together. And that can be even more complicated in a larger industry. So making sure that everyone's code is on the same syntax and it's going to work when you put it together is important. So thanks for watching. I hope code is clear.